Morning, everyone. Thanks for coming out to the early morning session here and everything. When I first found out that we were at 9 a.m. on a Sunday, I was like, oh, there's going to be a total of 3 people, counting Rick and I and the cameraman and everything. So appreciate you waking up and coming out here. Before we get started into the presentation, I'm Justin Leapline, Rick Yocum. He doesn't like the Twitter. And when I was making the cover page and everything, I was like, man, it's so annoying that, have the Twitter, handle and everything, and he doesn't have one, so I decided to create him one. And unfortunately, if you're following on Twitter, I said to keep it a secret. Somebody blew that the other day and everything. Yeah, but they did not. Yeah, somebody was trying to reach out to him and like, Rick, you never respond to me. He's like, what are you talking about? He's like, I reached out to you on Twitter and you're not responding. And he's like, well, I'm not on Twitter. He's like, yeah, you are. Type of thing. So, but we'll go through it a little bit and go over that story a little bit. So, of course, I had to create a good Twitter account, and with the help of some of the people at TrustedSec and some of our friends, decided to start filling it up. I gave them, some people to follow, just to make sure, had the good timeline and everything. And, of course, doing some tweets, and then people just love tweeting back, to this. And in fact, there's a number of people that just really contribute to all this stuff. And then, Dave and Martin were totally on board. They gave the spot of approval for this. And it was actually funny. This morning I woke up, got my phone, looking over, some of the emails. And, of course, I see this from the Rick Yocum account I created. You've got 121 recent notifications from Twitter. I think it's more popular than my Twitter account.
CML is a solution to some problems that don't exist. Good. Don't do that. It's not applicable to everything, right? So we took a step back and said, okay, how do we want to solve this problem? Does machine learning actually fit? And full disclosure, neither of us are data scientists, right? And sort of the point of this is, can you do machine learning stuff without a deep bed of data science, right? There's tons of stuff out there right now. Google has stuff, Amazon has stuff. There's a bunch of free resources that you can use. So as we thought about the problem, we rattled through it. And again, there's a lot of questions you should actually ask to see if the problem that you have, you might want to use machine learning to help solve. But it distills into a couple really big ones, or at least these are some of the first ones you should ask, right? Can you clearly state your problem? If your problem is we don't have machine learning, that's not a problem to solve by getting machine learning. That's not a business issue that you're trying to fix. Right. Is machine learning good at these types of problems? So machine learning is a ton of math in the background, and there are some algorithms that are very good at doing certain types of things. There are other certain types of things that they're not particularly good at yet, or the jury's out as to whether or not they can get good at it. At the end of the day, the problems that machine learning tend to be really good at solving are pattern recognition problems. So if you can fit your business issue into a pattern recognition context, it's probably an okay fit, or you can at least start thinking about it. And then do you have the right data? So the thing with machine learning is you got to throw a ton of data at the problem to actually train a machine to do the thinking for you. Everyone in this room is an expert in security stuff, or maybe some people are learning about security stuff, but experts in various domains. And there's that sort of old heuristic. It takes about 10,000 hours to get really, really good at something. It's not that much different from an ML perspective, right? Think what 10,000 hours means in terms of human understanding and all the data points that get correlated at that point in time. Computers need a lot of data to be able to think on your behalf. And they're still not going to be perfect, right? They're going to give you shortcuts to the right answers. So how did we go about thinking about this?
So our kind of theory on this and methodology that we're approaching is we have 2 disparate things. And keep in mind, all that we're doing here, I don't even say we solved the problem through this, and you'll see some of the results we got. But our theory on this is that we wanted to first do a proof of concept to actually understand this. And our proof of concept consisted of taking one disparate framework after we actually train the model and everything like that, and end up that it would actually map one way to another framework. And that was kind of our first proof of concept of this. We'll talk about little lessons learned in the future with this, but we're hoping that we can actually go the other way, and you can actually reverse that. But our first thing is we want to take one standard, upload another standard, and see where the overlays are. And there could be one-for-one mapping, as some of it, or it could be multiple controls that actually tie into that there.
So we kind of thought about it a little bit about, okay, well, highest level, 3 steps. Right? 1, let's start by training the system to annotate the statements themselves, right? If we can pull out keywords, right? This is an actor in terms of control. This is the target of a control. Here's some scoping related words to the control. Here's a time frame to the control, right? If we figure out what those keywords are, we can pull those out of statements. Now we can start to compare without all the middle filler words or without some of the suffixes or prefixes of words or the intricacies of the English language. So let's start by figuring out if we can pull out keywords. If we can, let's compare them. Let's figure out a way to do the comparison and kind of rank how much of a match do we think this statement, or equal these 4 keywords, matches this statement, or equal these different 4, these 5, or these 12 keywords. How much does that match, right? And 3 is actually, okay, great, now that we have this list of requirement A and requirement B and it's a 60% match, how do you use it? Good. Well, we're going to use it to focus compliance activities, right? If my executive team wants me to implement a new framework, or there's a new contract with 1 million requirements that comes through, and I know that I'm doing these 50 things because that's what my internal control framework says, if I can press a button, it spits out, cool, these pages of the contract you don't got to worry about. You're very confident you're doing these 30 things, at least from a security practitioner perspective. Lawyers should still probably do it. But these 3 at the end, though, you really got to think about these. We found no match for these kind of security concepts in your core control framework. So we really got to think about those. And the ones in the middle with sort of that middling, confidence threshold, well, think through them, see if you match. Maybe you only match part of the scope. Maybe you need to expand the process, right? But just to really help quickly focus where you drive the program based on the documents that continue to come in. And if any of you are responsible for reviewing inbound and outbound contracts in an organization, something like this, in my prior life, a ton. So we decided to work with Google, use its natural language functionality, and just start by annotating, right? And just pick out a couple really broad categories. So we have actions, we have scoping words, and we have target words for controls. And this is really kind of what it looks like when you either manually annotate a control using the entity extraction function in the Google Cloud Platform, or if it annotates it for you based on training data, it spits something out that looks like this, right? And you get a whole page of individual control requirements that have actions highlighted in yellow or whatever, and whatever the color coding you decide to use is. So, and in a really high level, this is how we're going to go about it. So we annotated, intentionally picked kind of small and similarly worded frameworks because annotating them manually is difficult, or time consuming. So we picked CIS Top 20, this TSF, and the 366 because they're all 100-ish in length, and you can annotate them out pretty quick. And then we threw those into Google AutoML as kind of like the training data, right? So this is what a target looks like. This is what an action looks like. And then we threw PCI DSS at it and said, hey, what's going to come out? And then we, built some stuff to say, confidence thresholds in terms of how we compare these.
That all this stuff of what we're pulling out with the different annotations and everything, that was only half the step. It was really just to get the extraction out of the actual comparison. We had to build that, type of thing. So it was a little bit of programming logic to actually take that, digest it, and connect it into the API, test it, throw it against the training model, and then see what came back from that perspective there. And
so kind of from a flow perspective, learn is like the first thing that we had to do. Again, we're not data scientists. We haven't done tons and tons of ML stuff in the past, so there's a ton of good free resources out there. So that's what we did first, and then select the frameworks that we're going to work with, right? And this is going to be part of sort of a recurring operational task, as we refine this, right? We'll pick a new framework, pick a new framework, pick a new framework, and every time we do, we're going to have to cleanse that data, right? Like we talked about before, it's not standardized, right? So cleanse that data so we can get in there, annotate it, right, manually, generally, until we get to a place where, in our case, Google Cloud Platform is consistently pulling out those keywords for us, right? Upload that data, train the data, extract it, build the calculator. Once we're only going to build it once, but we'll constantly be tweaking it, and then compare the data, right? So operationally, that's kind of the flow that we go through to do this. And there were some challenges. So when Justin first wanted to talk to me about this stuff, he had already run through a lot of the free machine learning stuff that Google had to offer, and everything sounded like a really great idea to me. But talking to him about it without having run through a lot of those free resources was extremely challenging. There's an entire lexicon of machine learning stuff that it's not one of those things where, oh yeah, I know about controls, and we want to do a machine learning thing. Let's just apply machine learning. It's a tool. It'll be easy. It doesn't really work like that. You really, if you want to start doing stuff, use the free resources that are out there. Run a couple of the free examples, through the paces, and you'll get a much better understanding before you dive in to do, your own security framework, control framework, stuff like that.
Yeah, and actually, one thing to mention about that, one of the things that they had to kind of prep your data, they had a script that helped annotate it, type of thing, that you basically pull a whole bunch of keywords and say, anytime this word shows up in this, annotate it this way. So it kind of helped prep a lot of our data with that. And it was a Python script. It was in their documentation on Google and everything. So I downloaded it, tried to run it, didn't work, type of thing. So it's one of those things we had to dive into the code, figure out where, from that perspective that, it wasn't working. So we had to tweak that just to even get it up off the ground. That was right out of their documentation.
Yeah, and the other thing about that script, the dictionary annotation style that's worth knowing is, so English is a very interesting language in that one word can mean a lot of different things based on context, right? So you might have one control that says inventory your assets. Okay, so inventory is my action and assets are my target. All right, fine. Or you should, right. Right, yeah, the one I like to think about is inventory your assets versus update your inventories. Oh, okay, so still inventory, keyword, it needs to be extracted. But in one, it's the action that you perform. In the other, it's the target that you're performing an action on. So the script in Google's documentation, it's great. It does what it says it should do as advertised. It'll pull out the word inventory, but you have to tell it whether it can only be one thing. And you have to tell it, oh, is this an action or is it a target? So we had to sort of build our own thing so that we could actually, because in the cloud you can manually annotate the same word as different keyword types, but the script to upload just doesn't work that way. So if you're looking to do this, you might need to put something together. Another big thing that we had to work through is, because I think I am so smart, we were talking about this stuff. It's like, oh yeah, controls. We know controls, right? It's going to be these 5 keywords. These are the exact things that we're going to need to pull out of control. So we actually started with 3, right? And I started trying to get into the control frameworks and annotate the data, and it was not perfect. Not even close, right? So, and the fact of the matter is the first 3 we started with was, okay, well, every control is going to have someone that has to do it. And there's going to be something that has to be done, and a frequency that has to be done at. Seems pretty reasonable. None of the controls are phrased that way, right? And frankly, in terms of the frameworks that we went through, most of them don't care who does the thing. If it's inventory or assets, there's no actor there. They don't care who does the inventory, it just needs to be done, right? A lot of frameworks also don't have frequencies clearly defined at a control-by-control level, right? I mean, they might say, assess your compliance with the framework annually, But whether you do a, constantly updating inventory, or you refresh your inventory monthly, or you refresh it yearly, certainly there are pros and cons, right, to doing it more frequently. But the control generally doesn't care. So frequency wasn't in most of the things either. And then in terms of the action itself, we had to split that apart then and say, update your inventory. That's actually two things. It's a thing that you're doing and a thing that you're doing it to, right? You have an action and a target. So the point here being, the framework that you use is going to be critical. It's going to drive the rest of this process, right? The keywords that you decide to pull out. And if you go into it thinking, yeah, conceptually I understand how this is going to work, right? When you dive into the data, that's going to change, full stop. When you actually get into the data to solve the problem that you're doing, you're going to find that you need to pull out different keywords than you initially anticipated. And that's fine. You just need to know that it's coming so that you're updating your framework once you really start to dig into the data. Right? So don't waste a lot of time working through the maze of how should we annotate this stuff. Just get into it and start annotating and update it. And when you feel good that you can annotate most of your stuff accurately, all right, go with that. We talked about this a little bit already. It takes a fair amount of time and effort to actually get the frameworks themselves into a format where you can compare apples to apples, right? So, the nice thing is, once it's done, you don't have to do it again for that framework, right? And it's just in there. Wow. But here's the thing. The nice thing is, the updates that occur to frameworks tend not to be wholesale changes of the structure of the framework itself, right? 853 is still going to be, here's the start of a sentence, here's 3 different middles of a sentence, and here's 10 different endings of the sentence. And they'll change the content on you, and you got to update to that. But it won't be major structural changes. So once that format's done, it's more tweaks than major issues. But it takes a while, and it's one of the most important things. Because if you're not cleansing the data, it's going to be very garbage and garbage. The other thing that takes a lot of time is annotating data. Right? Running through the 3 small frameworks that we did ended up being like 400 individual control statements. Annotating, and some of them have multiple actors, some of them have multiple targets. Many of them have multiple scoping groups. I think at the end we had about 1,500 data points that we threw into the machine, and it's not enough. Right? Well, we're going to have to continue to annotate, continue to make the thing smarter, but you need to have, you need to keep in mind that this is going to take a lot of time. It's not just, we're going to throw a computer at the problem and it's going to do the thing. It's going to be done. Training it is the hardest part, but ideally, once that's done, you can just reuse that knowledge to continue moving forward.
Yeah, and one of the things too, on our initial assumptions, one of it was the iterative process that we're going to categorize. So does it have to be done on a monthly basis, annual, all that stuff and everything. One of the things we quickly found out was when we were training the model, we didn't have enough data points to even start training the model, type of thing. So we actually had to hold that back, for our initial proof of concept, even though that's a good critical thing to measure, like an annual pen test, that's part of the requirement there. But we just didn't have enough data points to even do anything with that.
Yeah, that's a great point. Because Google Cloud Platform specifically, and different tools are going to do this differently, but they require for you to actually do training and model, they require at least 100 data points. So each category of keyword, if I didn't have 100 things that actually had a frequency attached to them, and I think when we ran through all 3 of these things, we had 10 frequencies, right? It just won't let you won't let you train at that data. So we don't have enough context to actually figure out what a frequency looks like. So we had to actually pull those additional keywords out, even though they were there sometimes, right? We had to pull them out. And we have the data, and eventually when we get to 100 things of frequency, it'll be part of the model. But yeah, it's a great point. Just the annotating itself requires a minimum amount of data, and Google particularly requires 100 instances of each type of keyword. So this was also a real fun one for a period of about 2 days. So So when you throw the data into the machine and click that button that says train, it's going to crunch it all and run it through all the algorithms, all the different data points. Yeah, 3 or 4 hours. Yeah, 3 or 4 hours for 400 control statements, right? Which is not actually a ton. When you actually get into it, like, that's a long time. And we were only extracting 3 keywords, right? It's 1,500 data points. There are data sets that are much, much larger. And as we iterated through this, and this probably doesn't scale, but I would expect it does up to like 1,000 or 1,500 controls, you can expect it to take about an hour for every 100 control statements, right? I'm sure that adjusts over time once we get into the thousands or whatever. But the NLP stuff is in beta. Google's natural language processing stuff, the entity extraction stuff, all that. So there was a day where we're trying to throw data into the system. It says internal error. And if you're familiar with Google Cloud Platform, internal error generally means our server did something. We know what it is. But we're not going to show you what it is for a couple different reasons. Try it again in a little bit, and just like, with exponential delays between the retries, right? So the problem with that, when you're working with all this data that's weird, and you're trying to cleanse data, and sometimes there's, from a character perspective, right? If Google doesn't want to deal with a non-standard character, you don't necessarily know if this issue is an actual Google internal error. Is it something because there's a character conversion error? Is it something else? Yeah. It probably took about an hour for me to realize that the apostrophes in this CSF are you're gonna get the words wrong, but they're the slanty tick marks that aren't okay. Yeah, they're the backticks. And so you manually convert it, right? And there's also, I forget the control, but there's a hidden character at the end of one of the statements as well that was super fun to troubleshoot. But again, we get through all that stuff, and then we get it uploaded once, and then like the next day it's like, oh, I added a little bit of data. Internal error. So anyway, the point is, sometimes stuff is just going to happen on Google's back end. Be prepared for that to potentially delay you as well. It only happened a couple times as we were really working through this. But it took about 2 days, yeah. But the problem is that because it takes like 6 hours before you know, or 4 hours, depending on how much data you're doing, before you know if you have a problem, right? You can lose a lot of time really quickly trying to upload the last framework that worked to see if it's something that you changed or something they did. So just, again, be prepared. It didn't happen a ton, but if it does happen, it might not be your fault.
So, finally, the results. So, I basically just did a little script that took 2 standards, compared it against model, and what we're looking at was a percentage of matching to the other controls, and we're looking at that from, does it match and how closely does it match. And I didn't actually do, an actual mapping. I just wanted to see percentage and, what the top 10 were that would match, and then compare that back to the thing we talked about before on what it should match and everything. So, here's the example, of the script and everything. I don't hear any grunts on the PHP script that I wrote and everything. But, on our first example that we did, so we want to kind of keep it similar on the IDE AM1. And looking at our controls and everything, here's some of the percentage that we're getting back. And keep in mind, the way the logic of the script works is I'm taking on the source framework there, I'm taking that and iterating it over every single control on the I call it destination one, which would be the PCI version here. And I'm looking at every single one and comparing it to each one of those controls. So basically, every single controller's PCI is compared to IDAM1, and then we're getting a percentage match, back to that and everything. So if we look at, the 3 we came down from saying, yes, these are absolutely matching, they're in the top, 6, there, type thing. And that's great, so we're getting a proof of concept that, it's getting there, those are matching controls based on the context of the annotations that are coming back when we're doing this. Now, if you notice, there's a few ones in between there that it's coming out, so if we take, 1 through 6 and actually validate, some of this stuff, looking at this control, reading this, that doesn't match at all, type thing. So we still have some work to do. but we want to show kind of the progression with that. Like the one control, Sarah 11.1.1 is the top match out of all the controls that we're actually going out of that, with some of the other ones as well. So it's close, but now we have to go back, look at the model, look at the data and everything, and do a little bit of debug, to actually get the better results of that. So it's a process, is basically what we're looking at here. So in the future, what we're going to be looking at.
Yeah, so obviously, the first thing we want to do is tuning, right? It's in some ways very much like a SEM, right? We caught the three things we wanted to catch, but we also caught some other false positives. So now we need to tweak, right, the comparison calculation to make sure that we're filtering out the bad stuff based on some other heuristics. The other thing, the next one, the two lines in the middle. So we found, it was very interesting as we started looking at the data, why we got some false positives. There's some controls that were auto-annotated, maybe just one word, right? So it just has an action word. And for some reason, because machine learning didn't catch it, or because the control is just stated in a different way, or maybe there's a misannotation somewhere. There's actually not enough information to meaningfully compare a statement that just has the word inventory with anything else that's in it. So we need to pare that down. We need to say, look, there's a minimum amount of data that you need annotated in each one of these controls to actually do a meaningful comparison. Right? A minimum amount of keywords that get pulled out from an ML perspective. The other thing that we're going to start looking at, probably once we get the tuning where we want it, is also using maybe a second round of machine learning to see if we can do the calculations with that. Right? So the comparison, right? Again, machine learning is really good at pattern recognition. So theoretically, again, if I can construct my problem such that, all right, now I know what these keywords are getting pulled out, I can say, well, here's a pattern of keywords. These keywords exist in this statement of text, and I think that's an inventory control. And I throw another thing at it from a machine learning perspective, and it says, hey, it's similar keywords. Is this an inventory control or is it not an inventory control? Right? So right now we're using a manual comparison calculator, and we'll probably do that for a while again because we're going to continue to work through the rules of tuning. But theoretically, you could probably run through an iteration of ML to extract the keywords themselves, and another iteration of ML to actually do the matching of the statements based on the extracted keywords.
The other thing we're going to be working on, obviously we've worked with a small subset of frameworks, adopting some more to get that better training and to get it a little bit more accurate. As you saw in our examples, we really haven't touched anything with privacy yet, which has its own different verbiage and, annotation, stuff with that. But pulling in some more so we get those better training models and a little bit more diverse, with that perspective. The other thing we're going to do, we didn't have anything with the machine learning model to actually validate it after. It was basically us running tests against it that was doing validation. We want to do some stuff where you can actually put a testing model next to the actual things being calculated and actually see the accuracy from that and get immediate respect to say, this is what looks right. And when I train my model, running up against that and saying, before we even get to the compare and contrast, like, is this right what it actually spit out, with that?
And one of the neat things about the way Google Cloud Platform does this is you can say, I want this data to be, annotated data, like framework data. I want this data to be testing data. I want this data to be training data. Like, you can build different data domains. If you don't do that at all, one of the neat things is it will, when you do an update or when you do a train, it'll peel out a percentage of, in our case, control statements to automatically test the recall and the accuracy. So we do have some of that, but we didn't choose what data was actually test data versus what data was trained data. It was just the random sample that Google actually pulled out. So we have some confidence percentiles in the mechanism right now in terms of how good Google thinks they are. But the challenge with that from an ML perspective is, again, if it's as part of its random sampling, it just happens to pull three controls that have very few annotations, right? Its actual percentage confidences in terms of the recall and the accuracy are going to be off because its validation data is not going to match. It's not going to fit the general information pattern of the regular statements. So there is some automated stuff in there, but we want to actually architect our test and training data to make sure that we're getting the right results. And after this, we might have touched on this before. From a contract perspective, right? We want to throw some very loosely structured contracts to this thing again because your organization probably isn't adopting a new framework every single day. Hopefully not. I feel really bad if that's the case. But depending on the size of your organization, it's very possible that you're having to deal with new contracts on a daily basis or multiple contracts on a daily basis. So we want to start to tune this so it's not just doing frameworks from a training perspective and all that, but it's also like we're using some contracts to help train it and to spit stuff out because I think that's where a lot of the operational benefit will come in.
Everything within the contract we're talking about, all those requirement riders that come along with it. Yeah, the appendices, whatever that may be. So talking about hey, you must do these 50 things if you're going to be, our customer and everything. So digesting those, compared against a base of what your company does, and then, looking at where those disparate differences are and what you need to go back to the negotiating table or, figure it within your pricing, whatever that. The last thing that one of the things that we found was a problem was getting normalized data from the control frameworks and everything. And this is a little side project I've had for a little while, but it's been on the back burner. We've done a lot of work in and around getting all the controls and put it into a normalized fashion, and we're going to be putting it out on GitHub on just normalize, if you want PCI data that's easily broken apart, it'll be in a JSON or YAML format. We haven't quite decided with that, but it'll be easily digestible. You can take it and, pull apart, here's the reference number, here's the control, here's the text to that with some, different fields and all that stuff. So we're going to be throwing that on GitHub, in the next week or two or something like that. So expect that kind of come out. And that's it. Yes. Rocking. Yeah. Yes. Because they came out with it. Yep. Because on the annotations, they came out with the exact same words and everything, is what it came out. So yeah, we dove into that quickly to see exactly what that was. And again, we have to go back because of the set that it pulled out with that. It just came out with the same three words, with it.
Tended to be small statements, intentionally so, because I went through 400 short controls. I don't want to go through 400 giant controls. But the long control had a lot of words in it, right? And so one of the things that we found is the contextual words in terms of the frameworks that we were doing. So we taught it the contextual words that we cared about, and it was good at pulling those out. But PCI has a whole different set of contextual words that machine learning that we didn't tell the ML framework how to deal with, right? So part of the reason that match the system thought it looked good but didn't is because there was a lot of context in terms of PCI. The machine learning just didn't even flag us. Oh yeah, these are probably the same things. Well, no, they're not, because the context is completely different, even though they share some of the same keywords. I don't know that we thought about too much. I mean, it probably makes sense as we go through it from when we do the GRC soup stuff. We'll probably find a way to tie it into that just as a resource that people are open to consume. We'll probably slow walk it, as we get through framework by framework. But yeah, as we do it, there's no reason that like others should have to redo it necessarily. Yeah, so we'll have to, and this is one of the things that we haven't really, run through yet, with contract being one of the next step type of thing. But I anticipate if there's an organization that really wanted to go this road, right, they'd probably want to update or standardize the format of the security addendums that they receive and or send, so that it matches a format that's consumable by this, and ultimately the GRC soup type format, which will all be kind of similarly put together. So just to make sure everyone could hear, so the question was, were we weighting the different keywords differently as part of the comparison? So maybe the action itself, the action matches, that's worth 60% of the equation, and if the target matches, it's worth an additional 30%, or a million other ways to do that. So the short answer is no, not in this pass, but that's absolutely something that we're going to be doing as we go forward tuning, because that's another critical component of why, to your point, or the question before, why certain things are currently seeming to be a match at the same weight, but they're not, because they might have matched on a contextual word, but the action and target are completely different. And those should be weighted higher. So that's certainly part of the tuning that we're going to be getting into. What does recovery mean in this context? So it's almost like their form of annotation to select what the word for this control actually means. What does inventory mean here? Is it something that you're doing, or is it something that's being done? But you have to do that for each control. And I haven't seen, they might have plans for this, but I don't know. I haven't seen anything in there that once you pick enough of those words, it'll automatically pick the rest of the words for you. I think it's going to be pretty consistently a manual thing. So that was part of our intent here, too, to see what we could make happen. Once we teach it enough stuff, what we could get done automatically. Well, but you're absolutely not wrong, though, because as part of doing this, we're thinking about other forks or ways that the data might be used. And one of the things that we sort of thought about was sort of like the Aristotle form control framework. What's that look like, right? Once you smush all this stuff together, right? Maybe not the ML stuff in terms of pattern recognition, but it's a sibling of ML being the AI stuff where you future cast, right? And sometimes future casting gives you like a pizza recipe that's like mushrooms and tomatoes and turkey and weird stuff, right? But one of the things that we thought about doing once we get this a little further is seeing if we can get the machine to automatically spit out what the sort of core combination of controls looks like. And you're absolutely right. By industry, it might look a little different, or by what you're trying to do, if it's privacy versus security versus compliance, it might be a little different. But we're absolutely thinking in that direction. So not necessarily forcing the big standards bodies to become standardized, right? But seeing if we can develop something as a side fork that, right. Another standard. No, that's a great question, and it's absolutely, I think, a way that you could utilize this data or these processes, right, to validate, right, the things that the team is doing in terms of, the manual mappings, or even like from risks to controls. Pick your two things that are comparable. Right. Right. Thanks, everyone.